Ever wonder how massive steel tubes slip through the ocean depths without leaving a trace? This deep dive exposes exactly how submarines are built, armed, and hidden beneath the waves, and you won't believe the secrets behind their stealth. Stick around, because the survival of entire nations can hinge on these underwater marvels. Pressure hull. A submarine's pressure hull is the fortress shielding its crew from ocean depths that could crush a human in an instant. Constructed from specialized steel or titanium, this main hull has just one job: keep everyone inside alive under the immense weight of the sea. Each metal plate is shaped into curved segments and meticulously welded together. Every weld undergoes extreme scrutiny, ultrasound checks, X-rays, you name it, to ensure there's zero chance of cracking. Once the hull passes inspection, it's split into compartments by watertight bulkheads. If one section floods, closed doors keep the rest of the sub dry, an essential lifeline when things go wrong. The final design also includes an outer hull that streamlines the shape, conceals the pressure hull beneath, and often contains the ballast tanks. This two-hull architecture bolsters both stealth and survival. Building the pressure hull requires a snail's pace of precision. Even the slightest misalignment can weaken the sub's ability to hold its shape at depth. The finished shell is repeatedly tested, first on land, then in the water. Engineers would rather spend months verifying every rivet than risk a structural flaw miles below the surface. After all, the hull is the heart and soul of any submarine. Buoyancy and ballast. Submarines don't just drop below the waves, they manage buoyancy with finesse. The main tool here is the set of ballast tanks between the pressure hull and outer hull. These tanks can fill with water or be purged with compressed air, allowing the sub to sink, hover, or rise. Achieving neutral buoyancy, where the sub neither sinks nor surfaces, saves energy and keeps the crew stealthy at a chosen depth. Trim tanks adjust fore and aft balance, preventing the nose or tail from pitching too high. Shifting water among these tanks helps maintain a level orientation. The key is careful coordination. If the submarine needs a quick dive, the crew floods the tanks to drop depth fast. To avoid detection, they might hover silently in the water column, using minute adjustments to keep from drifting up or down. Managing these tanks takes plenty of practice. Naval crews are trained to track water density, salinity, and temperature changes that can alter buoyancy. That's especially important in areas with rapid temperature gradients. Fill a ballast tank at the wrong time, and you might bob to the surface like a cork or plunge deeper than intended. Such slip-ups are more than embarrassing. They reveal a sub's location to anyone watching. Propulsion and stealth. The difference between a safe mission and a tragic ending often hinges on how quietly a sub can move. Nuclear-powered vessels use reactors that produce steam, which spins turbines for propulsion. This power system lets them remain underwater for months. Diesel-electric subs rely on engines that charge massive batteries. They're exceptionally quiet underwater because battery-driven electric motors barely hum, though these subs must surface more often to recharge. Reducing noise is an art form. Pumps and machinery are mounted on shock-absorbing frames, while hulls sport sound-dampening coatings called anechoic tiles. Some advanced boats even use pump jets instead of propellers, channeling water through ducted fans to limit cavitation, a fancy term for bubbles that can create telltale noise. Underwater, small sounds travel long distances, so every mechanical whir risks detection. And stealth isn't only about muffling engines. Crews follow strict quiet ship protocols. Non-essential gear is turned off, and sailors tiptoe around to avoid rattling equipment. Minimizing electromagnetic emissions is crucial too. Turn on a radar at the wrong moment and you'll announce your presence to anyone listening. Through training and discipline, submariners perfect the fine balance between staying undetected and accomplishing the mission. Eyes in the dark. Underwater, eyesight is limited, so submarines rely on sonar, listening to or actively pinging the ocean for echoes. Passive sonar simply hears what's around, detecting distant ship engines, whale calls, or enemy torpedoes. Active sonar sends out a signal and measures the returning echo to map objects in the vicinity. It's incredibly useful, but compromises stealth because an active ping can be traced. Modern subs combine passive and active methods, supported by advanced software that interprets even faint signals. Operators can filter out background noise or marine life chatter to isolate targets of interest. This high-tech approach transforms random blips into an underwater landscape. Imagine turning every sound wave into a 3D map that highlights ships, seafloor features, and potential threats. Additional sensors often include periscopes and photonic masts for surface viewing. These instruments may carry cameras, infrared detectors, and electronic receivers. Submarines also have electronic warfare systems to detect incoming radar signals. The result is a comprehensive picture of what's happening in every direction, even without a direct line of sight. In the silent world beneath the waves, data from sensors is invaluable and can mean the difference between evading detection and becoming a target. Weapons and defenses. Armed to the teeth, submarines can deploy various weapons. Torpedoes remain the classic choice, tube-launched, self-propelled, and equipped with guidance systems. Some are wire-guided, receiving real-time course updates from the sub. Others are fully autonomous, homing in on targets via onboard sensors. As soon as a torpedo leaves its tube, it's game on. Targets have to scramble, launch countermeasures, or pray they can outrun it. Many submarines also carry cruise missiles, able to strike coastal or inland targets from hundreds of miles away. By staying submerged until the last moment, the sub preserves its stealth advantage. Ballistic missile submarines are another league entirely. Known for carrying nuclear payloads, they lurk in deep oceans, forming a major piece of a nation's nuclear deterrent strategy. Finding one of these lurking juggernauts is a needle-in-a-haystack proposition for adversaries. Defense systems are just as critical. Subs can release decoys, devices that mimic the sub's acoustic signature to fool enemy torpedoes. Evasive maneuvers involve quick dives, turns, and shifts in speed. Crews also keep an eye on incoming signals, using sonar to gauge how fast an attacker's torpedo is closing in. If the sub can disrupt its pursuer's guidance long enough, it might slip away. The human factor. Building and arming a submarine is only half the challenge. The other half is keeping the crew sane and safe in a metal tube underwater for weeks on end. Quarters are cramped, storage space is scarce, and personal privacy is minimal. Hot racking, a practice where multiple sailors share the same bunk in rotating shifts, is a common reality. Meals, daily tasks, and drills form a structured routine that keeps everyone focused. The control room is always staffed. Someone pilots the sub, others monitor sonar, and yet another group stands by in the engineering spaces. Because communication with the outside world is limited, the crew relies on each other for entertainment and morale. Card games, movies, or short workouts in makeshift gyms help pass the time. Submarine duty demands psychological resilience. Claustrophobia is not an option, nor is panic. Training covers emergency scenarios like fires or flooding because there's no escaping to open air. Submariners trust each other deeply. Everyone's safety depends on collective competence. Despite the stress, some sailors love the camaraderie, describing the sub as a second home beneath the sea. Building and testing. The path from blueprint to actual submarine can span a decade. Once officials decide on a design, whether for coastal patrol or nuclear deterrence, shipyards begin fabricating hull sections. These rings are later welded into the main cylinder, which becomes the pressure hull. Throughout this process, each weld is inspected, each plate tested for strength, and each seam meticulously sealed. Major components, reactors, engines, and sonar arrays arrive in modules. Specialized teams install them within the hull, threading cables and plumbing through tight corridors. Once the vessel is structurally complete, the submarine is transferred from the assembly site into the water. At that stage, a barrage of tests begins. Does it maintain proper buoyancy? Can it dive and resurface smoothly? Are all weapon systems functional? Sea trials put every system through its paces. Naval inspectors and engineers record speed, noise levels, sonar clarity, and more. They also run simulated combat drills. If any flaws surface, the submarine goes back to the shipyard for corrections. That cycle repeats until the sub meets strict naval standards. After commissioning, further upgrades will happen throughout its service life. Submarines remain in operation for decades, so builders plan with long-term maintenance and retrofits in mind. The future of underwater warfare. Submarine technology is advancing rapidly. Unmanned underwater vehicles, UUVs, are emerging, allowing subs to expand surveillance without risking a crew. These drone-like crafts can roam ahead, gather intel, or even lay mines. Artificial intelligence may soon coordinate multiple UUVs, creating a network that stretches across miles of open ocean. New propulsion methods include air-independent systems, giving diesel-electric subs more underwater endurance. Some research focuses on superconducting motors that could operate almost silently. Meanwhile, material science could yield stronger, lighter hulls, enabling deeper dives and bigger payloads. The arms race continues in stealth coatings, sonar countermeasures, and electronic warfare, ensuring tomorrow's submarines remain as elusive as ever. Detection technologies are also improving. Undersea sensor networks and satellites may eventually spot anomalies that hint at a sub's location. This will spark fresh innovations in submarine design, fueling a cycle of stealth versus detection. Yet one truth stays constant: a hidden submarine poses a strategic advantage. Whether delivering covert surveillance or a ballistic missile payload, it holds power that shapes geopolitical calculations. Now that you know how submarines are made, you're probably wondering how they stack up against other military machines. Curious? Click here to dive into our next video, where we explore the building of America's most powerful fighter jets. Trust me, you don't want to miss it.